Good morning, children. Hope you all are fine. I welcome you all to this session of physics, and we are still on the chapter heat. And in my previous two sessions, we have seen what is heat, right? What are the various units of heat, and what are the various thermometers which are used. And now we are on to the transfer of heat, and we have seen the three types of transfers: conduction, convection, and radiation, and now it's time to study them in detail, right? Okay, if we heat one and see, children, the best depiction is of conduction is given here. See, if we do so, then our hand will feel the heat. Why? Because from the burner side the heat is gets transferred towards through the spoon or the utensil at the top. It gets transferred towards our hand and we feel the hot. Now if we put the same take the same spoon and uh, let somebody else touch it, then the heat is transferred into the other spoon also, right? The heat gets transferred into the other spoon, right? So we can say, because the other spoon was cold and the main spoon was heated, and so it was hot, so we can say that the heat is transferred from a hot region to a cold region, right? Heat is transferred from a hotter end of the spoon to a colder end, or from a hotter spoon to a colder spoon, right? So conduction is the transfer of heat from the hotter part of a material to its colder part when the hot material and its cold material are in contact, right? See, contact is very important. See, just like this, the contact is very important, right? So there is some activity given in your book which you can go through, right? This transfer of heat process is takes place by conduction, right? Takes place by conduction. The transfer of heat in liquids and gases, however, takes place by the process of convection, right? Convection is the transfer of heat from hotter part of the liquid to the colder part of the liquid, uh, right? The transfer of heat by convection can take place only in liquid and gases because the particles are allowed to move freely, right? So in gases and liquids the transfer occurs by convection. Okay, now there is convection in air also. Air is a very poor conductor of heat, so air cannot transfer heat by the process of conduction. Air transfers heat from hotter part to its colder part by the process of convection, by moving itself. It moves, it grabs the heat, it moves, right? It moves from one place to the other, thus heating the other place, the other at the other place. Now this is how the heat travels. This is how the convection process occurs. In your houses also you would have seen the convection uh, cookers are also there, pressure, right? Okay, it so happens, see children, this is a very common example that when heater is kept on the floor in a room or switched off, the heater gets heated and expands and becomes lighter, the right? So the air gets heated up, right? The air gets heated up, and it expands and becomes lighter and starts moving, and within a short duration of time, we can see that the entire room gets heated up, right? As the cold air moves from down to up, right? Okay. Now, children, another very classical example of convection is the blowing of sea breeze and land breeze, right? Gentle wind is called breeze. The people living in coastal areas experience an interesting phenomenon called land breeze and sea breeze. During the daytime, what happens is when the sun shines, the solid land gets heated to a higher temperature, right? And more quickly than the liquid sea water. So, what happens here is the hot air over the land rises up and moves towards the sea. So, it rises up, and then the cold air from the sea comes and takes its place. So, the wind is now blowing from sea to land, right? And this breeze is called sea breeze. See, children, this is a very important phenomenon, right? So, in sea breeze, the movement is from sea to land, right? Remember this, because in daytime it occurs in daytime, because in daytime what happens, the land gets heated up, so the air rises and there is a vacuum in the land, and so the air from the sea moves up, right? See, this is a pictorial representation of the sea breeze, right? What happens at the night time is just the reverse. The hot land gets cool faster, but the water of the sea, it does not cools so equally faster. So the air in the sea, it rises up, right? Being hotter, it rises up, creating a vacuum there. So air from the land moves to the sea, and this is called land breeze, right, children? This is called land breeze, right? So these are some, see, this is the diagram of the land breeze here, right? You see the direction of the flow of wind. Okay. Next is radiation, right? See, when we switch on an electric bulb, it becomes hot and gives out heat and light. Now, if we keep our hands at a short distance from the glowing bulb, we can feel the heat. Neither we are in contact with the bulb nor anything is moving here and there. Still, we feel the heat, right? This means that the hot glowing bulb is transferring some of its heat to our hand held below it. The hot electric bulb cannot transfer its heat to our hand by conduction because air is a poor conductor of heat. The hot bulb cannot transfer its heat to our hand by convection because convection currents of air always carry heat in upward direction. But how the heat is coming to our hand is through the process of radiation, right? Now what happens is every hot object emits, see children, we are here. Every hot object emits, gives out invisible heat rays in all directions. These heat rays carry heat energy. When these heat rays fall on a cold object, the cold object receives heat energy and gets heated by this. Heat energy is transferred from hot object to cold object by means of heat rays. This method of transfer of heat energy by heat rays is called radiation. So heat can be transferred from a hot body to a cold body by radiation, even if there is no material medium like solid, liquids or gas in between. And this is, children, you will be very surprised to know this is the phenomenon by which the heat of the sun reaches earth, right? See, it is mentioned here in this paragraph. Radiation is the transfer of heat energy from a hot body to a cold body by means of heat rays. without any material medium between them. The best example of radiation is the transfer of heat energy of sun to the earth. When we come out in sunshine, we feel hot. This means that heat from sun is being transferred to us, which makes us feel hot. Right? Now, how does this happen? The sun is an extremely hot object. The sun emits heat radiations in all directions, and these heat radiation travel through a vacuum between the sun and the earth at a very high speed and reach the earth. And this is how the earth gets heated up. Right? See, this is the diagram also of radiation. Right? Now we can see there are many examples of this. When we stand next to a burning fire, we can feel the heat of the fire falling on our face. Right? During Holi festival, when we burn any fire, right? We feel it. When we sit in front of a room heater, we get heat directly from the process of radiation. A hot utensil kept away from flame cools down by transferring its heat. Right? Food, depending on temperature of surrounding, our body too gets heat. Now, absorbers of radiation. The amount of heat which an object can absorb by radiation depends on the color of the object. The object having dark color absorbs more heat, with the objects with light color they absorb less heat, and this is one of the reason why we wear hot clothes during summer and cold clothes during we wear uh, light clothes during summer and we wear darker clothes during winters, right? Now this is an activity given here. So we move to now to emitters of heat radiation, and the amount of heat which an hot object can emit by radiation also depends upon the color of the object. The hot object having dark colors emit more heat, and the way having light than those with light colors. Right. Next is a comparison between conduction, convection, and radiation. Conduction: the molecules of the medium do not leave their mean position. In convection, they leave their mean position, and in radiation, the medium remains unaffected. The medium is required for the transfer of heat by conduction. In convection, the medium is required for the transfer. In radiation, no, it is not required. Conduction: the transfer of heat can be in any direction. The transfer of heat is in the vertically upward direction. The transfer of heat is in all direction. The process is slow, the process is faster in convection and the fastest in radiation. And now we are on to thermos flask, which is their very common thing in our houses. The vacuum of thermos flask keeps tea or ice creams tea hot or ice creams cold. Right? It is achieved by minimizing the heat loss due to conduction, convection, and radiation. See, children, this is the setup here. It is double walled glass bottle. The air between the wall is removed. The inner side of the outer wall, and the outer side of the inner wall are all silvered. The bottle is enclosed in a plastic case with a stopper made of plastic. The plastic case and the stopper minimize the loss of heat by conduction. The vacuum between the walls minimized by convection. The silvering lining it minimizes heat loss by radiation. So the substance remain the same, right? And you can see this in this diagram also. So with that we come to the end of the chapter, and I stop here. I hope you enjoyed it as much as I did in making it, and until we meet again, it's a goodbye.